Welcome back. In today's lesson, we're going to be looking at the slope of a line segment. Now, we're doing this in our linear equations section for a certain reason. So slope here deals with the steepness of a line segment. Okay? So in other words, it deals with the steepness of our graph. So it is the ratio of the rise, which is the change in height between endpoints, and the run, which is the change in horizontal between endpoints. Okay? So in other words, what we are looking at here is the change in our rise divided by our change in run is equal to our slope. If the rise is always going to be positive if we're going up, and it's also going to be positive if we are going to the right. So let's take a look at our first example here. We are looking at certain line segments here, okay? And we want to find the slope of each of these line segments. So first step is we have to find my rise. So if we look at that, that is my change in y. So we're looking at A and B. My rise is I go from A to B, I'm going up 1, 2. So I'm going up 2. Now I'm going over 1, 2, 3, 4, 5, 6, 7. And I'm going over 7. So my slope of this thing here is going to be 2 divided by 7. Let's take a look at my next one, CD. So we're going from C all the way down to D. So this is going to be a negative because we are moving down. And whenever we move down, it's going to be a negative. So I'm going to go 1, 2, 3, 4, 5. So we go down 5. Now, we're also going over to the left, which is also negative. So I have 1, 2, 3, 4. So that's going to give me negative 5 divided by negative 4 to give me my slope, which is just going to give me 5 over 4. Let's take a look at my next one, EF. So here is EF. I am moving down 1, 2, 3, 4, 5. So I'm moving down 5. And I'm moving in a positive way, because going in this direction is positive, 1, 2, 3. So I'm moving positive 3. So that gives me negative 5 over 3. If we look at slope, we're looking here at a change of y divided by a change of x. So if this was a graph, normally I'd have a value here, maybe time, in my x, and I'd have maybe a value here of distance in my y. So if we kind of look at this, what this is saying is my change in distance as a result of my change in time is my slope. So what is the average change in distance divided by change in time? So basically slope is comparing two different variables and how they relate to each other. So right here, there is an investigation for you to do. So basically what it wants it to do is we're going to look at these 3 points all along this one straight line. Okay? So if I look at the rise from A to B, we go up 1, 2. Now I look at the run, we go up 1, 2, 3. So my slope is 2 over 3. Now if I look at AC, my rise is also 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, we have 8. And now my run, which is going to be B, sorry, A to C is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is going to be 12, which gives me 8 over 12. And now if I was to simplify this fraction, that is once again the same as 2 over 3. Okay? Now let's try my next one here. We want AD. So if I go to 8D, I know this is 12 to here, And so I'm going to go 1, 2, 3 more. So that's going to be 15 is my run. And my height, we know it is 8 up to there. So I'm going to go 1, 2 more for my height, which will give me 10. Which gives me 10 over 12, which is the same as 2 over 3. We're starting to notice something here. We have one line, and the line is straight. And we're saying the ratio of this line, the slope of the ratio between the change in y divided by the change in x, anywhere on the line so far is the same. Let's see if that's true from B to C. So if I look at B to C, I go up 1, 2, 3, 4, 5, 6, and I'm going over 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 6 and 9, which is again simplified to 2 over 3. So what this investigation shows us is no matter what, on this straight line here, anytime we have a straight line, our slope will always be the same. What that's saying is, for every time we change in y, we're going to change the same amount in x, no matter where we look on this line. Okay? So in other words, x affects y at the same rate on this line. That's what it's saying. So when we get looking at word problems a bit later, we're going to say, if we're looking at how many hours you worked versus how much money you made, normally if you're getting paid per hour, what's that saying is, well, if you work 3 hours, you still expect to get paid $15 an hour, as if you work 10 hours, you're still going to get paid $15 an hour. So the relationship between the amount you get paid as a result of the amount of hours you worked should be the same. Okay? So this next part here, we're looking at certain other lines for this investigation. So the first one is this first grid here. We're looking at all horizontal lines. Now the slope, remember, is our change in y. So if we look at these lines, there is absolutely no change in y, divided by the change in x. Well, so for everything in grid 1, my slopes are going to be 0 divided by, well, some number here, because my change in x here is maybe 8, okay? Divided by 8, which is equal to 0. Now this one here, I look at, I think I have 11, so it's 0 divided by 11, but doesn't matter, it's going to be 0. All of these here are going to be equal to 0. The next one here, grid 2, we are looking at vertical lines. So in this case here, we have a change of altogether 10. And now we're dividing this here by, well, there's no change in x, so that's 0. Now, anytime we try and divide by 0, what do we get? That's impossible to do. So this is going to be called undefined. Let's look at my other ones. Look at this one here. We have a difference of 7 up and down. So 7 divided by, and there's no change, 7 divided by 0, and we cannot divide by 0. You can punch in your calculator and it won't give you an answer. It is undefined. So essentially, anytime we have a vertical line, my slope is undefined. So horizontal line segments have a slope of 0. Okay, all of these have a slope of 0, and anything that's a vertical line has an undefined slope. Okay? All right. So now let's look at my third investigation here. In this third investigation, all it's doing is we're looking at these two graphs, and you'll end up figuring out that anytime we go, if we're moving from left to right, and we're moving uphill, that means these are all going to be positive slopes. Anytime moving from left to right and we're moving down, and our graph is going down, this is going to give you a negative slope. So that's the whole purpose of that little investigation there. So here is my next class example. And it has a picture here where we put a grid on. And based on this, we want to find the slope of this roof. So I'm trying to figure out how steep is this roof line right here. Okay? Here's my roof, and we want to figure out how steep is that line. Now, what I want to do is find my change in x and my change in y. So I look right here, I'm going to find any 2 points that we learned before we could take on the graph, which we could read. So I look, here's 1 point I could read, And the next point is, I'm going to say around right there. So in this case, every time I move over, 1, 2, 3, I go up 1. And it's going up positive, so my slope here is 1 over 3. Okay? So let's go to that again. So my change in y is 1 for every 3 I go over. I could take this almost anywhere on this one here. So it looks like we start right there. Here's another point. And it looks like I go up 1, and then I go over 1, 2, 3 to get to the next point. So no matter where we look on that line, my slope is 1 over 3. My change in y is 1 per every 3 change in x. Okay? Now let's look at example number 3. In this example here, it says draw a line segment on the grid which passes through point -4, 2. So I'm going to look here and go -4. So always is x first and then y when we're doing our grids, because x comes before y in the alphabet. So I'm going to go -4, and then we want to go 2 up. So here is my point. Okay? And it says we have a slope of 2 over 3. Well, if you remember, this is my change in y, and this is my change in x. Now, the fact that it's negative means that if we're going from left to right, we must be going downward. So in that case, I'm going to go 2 down. So my change in y goes 2 down, because it's negative, 1, 2. For every 3, I move over to the right. So 2 down, and then 1, 2, 3. Okay? So here is another point on the line segment. But it says it wants 3 other points. So let's try another point. And now remember, my ratio here is for every time y goes down 2, 1, 2, we go over 1, 2, 3. And there I get my other point. Now, I could even go in the other direction. So if I was saying every time we go up 2, well, that must mean then my bottom one must be negative, because we have a negative here fraction. That means either my numerator or denominator is negative. So I'm going to go up 2, 1, 2, and that means I must move over that way into the negative, which is going to be 1, 2, 3. And if I were to connect all of these lines, it would be still a nice, perfectly straight line. Okay? So that is how we would do that one. Now our last question here is a line segment that has a slope of -5 over 7 and a rise of 12. So let's look at this again. My slope is equal to change in y all over change in x, which is equal to -5 divided by 7. Okay? Now, it's saying we have a rise of 12. So this is my general change, and we have a rise of 12, so this here is my y value, my y change. So we're going to say this here is the same as 12 over, and now we want to find my change in x. Okay, so if we raise 12, what is going to be the change in x? So let's think of it this way. So let's say x is my time. So in every 7 minutes, I'm super fast, and I run 5 kilometers. Okay, or I'm walking. And every 7 hours, I walked 5 kilometers. I was super slow. Now, what that means is then, how long would it take me to do a total of 12 kilometers? Well, I would have to try and make this ratio, and we're going to now solve for x. So I have -5 over 7 is equal to 12 over x. So now that we want to solve for x, we want to get x all by itself. So first I'm going to multiply x by both sides. So these x's will cancel off, and now I don't have x as a denominator. So I have -5 over 7, x is equal to 12. Now I'm going to multiply both sides by 7 to get rid of these 7's. And then I'm going to divide both sides by -5. That will cancel off those 5. So that isolated x. So I ended up getting now 7 times 12 is 84 all over 5. okay? Which is equal to 16, negative 16 and 4/5.